Good morning, guys. I hope you're doing well. Just want to warn you that there are officially 8 new cases of the coronavirus reported in Uganda. So you guys, please be safe. Don't talk to people. No, just kidding. Talk. Stay away from social interactions or places or friends or something. Talk to them on your phones, etc. But be extra careful. Right. Yesterday we talked about factorization. Some people spell it with the S, some people spell it with the Z. I am on the S team, obviously. I want to start by going over a question that Aurora asked, or a question that looks like it. This is not the question Aurora asked, but it's just an example of questions that look like this. So if I have x maybe to the power 7, y, and then minus x to the power 3, y to the power 2. You'll see this a lot. Every time you want to factorize something that looks like this, you're basically looking for what are the smallest powers of each of these terms that I can take out. So if I start with the x, the smallest power of x is this right here. And the smallest power of y is this right here. So since those are the smallest powers and x and y are all common to each of the terms, there's x and y in that term, x and y in that term, x and y in that term, I'll take out those smallest powers. I'll take out x squared times y. If I take out x squared times y from this right here, I am left with just y to the third power. Because x squared is already taken out, and y to the power 4, if I took out y to the power 1 already, then I have y to the power 3 left. Right, next to the next one, plus this is x to the power 7. If I already took out x to the power 2, then I have x to the power 5 left. And if I already took out y, then I don't have anything here. This is x to the power 3. If I already took out x to the power 2, I have just x left. And if I already took out y from here, then I have just y left. So my final answer is right there. Yeah. Alright, so today I want us to look at factoring trinomials. Cool handwriting. That one says trinomials. You can look up the spelling. No, I'll just write it again. Trinomials. There you go. A trinomial, also called a quadratic equation, is any expression of the form ax squared plus bx plus c. If something looks like this, it's a trinomial or a quadratic equation. It's an equation if it's equal to something. So if it is equal to something, say equal to 0, and you want to solve it, then it's a quadratic equation. This is called the quadratic term, this is called the linear term, and this is the constant term. Quadratic, linear, constant. So yeah, that's a quadratic equation or a trinomial. We already looked at how to factor trinomials in 8th grade and 9th grade, but and we used very cheap indirect method. So this time, since you guys are getting older, you're getting smarter, I want us to use a more direct approach when factorizing these trinomials. First example we're going to look at is if I want to factor something like this, plus 6. If I want to factor it, quite simply, every time I'm factoring something like this, I look for the numbers in front of the quadratic term and the constant term. Those are the two numbers I look at. When I look at those two numbers, there's one here. When I look at those two numbers, then I try to figure out how can I manipulate these two numbers together to get that number. That's the basic idea. That's what we're trying to do today. How can I manipulate these two numbers together to get that number using their factors? Now I know that 1 or x squared, 1x squared is the same as x times x, right? And I also know that 6 can be written as 6 times 1. Once I have the factors, I ask myself, what combinations of these factors can give me 5? If I take 6 times x, this right here, 6 times x, and I add it, we're always adding, 6 times x, and I add it to 1 times x, does that give me 5? Currently the answer is no, that doesn't give me 5. So the factors of 6, which are 6 and 1, will not help me. Then I go to the next factors, 2 and 3. If I get x and multiply it by 2, right, that, and then I get x and multiply it by 3, and then afterwards I add them, do they give me 5? Let's see. X times 2 is 2x. X times 3 is 3x. Move. 3x. 3x plus 2x, does it give me 5? Yes. This doesn't even need to be written. It can just happen in your head. So since that gives me 5, I know that my factors are x plus 2 and x plus 3. I have factorized. Just some recap. I look for these two numbers, the constant term and the quadratic term and the constant term. Try to manipulate them to get the linear term or the linear coefficient. That's what we're doing. And you might wonder, why do we always add these two numbers? Why do I add 2x plus 3x? Just something I forgot to tell you about is in this expression, the solutions to a quadratic expression are called roots of an equation. Those are basically the numbers that you can plug into this expression to get 0. Since they're called roots, this number c is the product of the roots. It's called the product of the roots. And this number b is called the sum of the roots. That's why we try to manipulate the expression, to try to manipulate these two numbers, this number and that number, to get us the sum, which is the middle number. This is just in case someone was wondering, why do we add them? Someone like Micah, or sure, someone else, or Claudian. So moving on, there is something called a prime trinomial. Simple example is x squared plus x plus 1. Now trinomials like this cannot be factored. You can try and 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 try again, but you still can't factor it. So all trinomials that cannot be factored, now like I said, you first try. Just because you can't factor it doesn't mean it cannot be factored. But if a trinomial truly cannot be factored, then it's called a prime trinomial that can be factored. And if we can just do one last example before we end it. If I have something like 2x squared plus, for something here, 2x squared to minus 5x, minus 5x minus 12y minus, just 12, minus 12. I want to factor this expression. Remember, I look at these two numbers, this one right here and this one right here, with its sign. Please always take it with its sign. And then I try to manipulate them together to give me the sum of the roots. So this is simple. The factors of 2 are just 2 and 1. If I want to get 2x squared, I'll just multiply 2x by x. Now, what factors of 12 am I going to use to get, to combine them with these ones right here so that I can get 5? That's all I want to know. What factors of 12 will I use to combine them with the factors of 2 to get 5? Let's do some trial and error. I can try 12 and 1. 12 and 1. Remember, we always do the cross. 12 and 1. 12 times x is 12x. Plus 2x times 1 is 14x. That's not going to work. Not going to work. Let's try 2 and 6. 2 times x is 2x. If I add that to 6 times 2, 12x. 10 plus 2, 12 plus 2 is still 14. Not going to work. Let me try 3 and 4. Let's try 3 and 4. Because 3 and 4 give you 12. 4 times 2 is 8. 4 times 2 is 8. Okay. 3, if I multiply 3 by x, I get 3x. 8x and 3x, I can work with them to give me 5x. Because if the 8 is negative and the 3 is positive, then it's going to give me 5x. Like again, I said, this needs to be happening in your head. So I know that if I put a negative on the 8, on the number that's giving me 8, if I put a negative on the 8, which is on the 4, then I should get what I need. So my factors are going to be 2x minus 4 times x plus 3. Just like that. Now, if I wanted to solve this, now we'll do that tomorrow. We'll do that some other time. Don't worry about that now. My last, very, very last question for you today is, I want you guys to tell me whether this x squared minus 9x, 9x minus 36, tell me whether it's prime or not. Right? If it's not prime, factorize it for me and tell me what is its factorization. Then write your answer in the comments. Thanks guys, have a good day.